Mr. Rainsberg here to go over the first video of Chapter 5, which deals with probability. This lesson 5.1a is going to be looking at introducing probability, some of the rules, interpretations, definitions. Before we go into that though, let's kind of look at where we've been in this course and where we're going. And we've been using this diagram to discuss where we've been and where we're going to see how the whole AP course for statistics relates and connects together. And so there's a population we want to know something about. And we did learn in Chapter 4 you could do a census, but that takes a lot of time, it costs a lot of money, could not even be feasible. And so a census, though it collect data over everybody in the population, can't really do a lot of times. So we said, okay, then we're going to collect a sample. But in order to collect a sample, we have to follow certain rules and make sure we do that properly. Are we using random selection? For doing a sample for a study, we can do stratified. Are we doing convenience? Because that's not good. What about if we're doing an experiment? Are we doing random assignment? Are we using blocking? And so we learned all the different ways in Chapter 4 that we can collect data that represents a sample. We even learned scope of inference based off random selection and random assignment. And once we collect that data, what are you going to do with it? Well, that was Chapters 1 through 3. We analyze the data. And once we analyze the data, we can look at it with numbers, percents, tables. We can look at it with graphs or even with words. Once we have all that, we're now going to be looking at probability. We're going to understand how we expect that data to behave based on the laws of probability. So we have this data over here that we've analyzed, but what should have happened, what should we have expected to happen over here based off of the laws of probability? And once we get that down over the next 3 chapters, we'll then learn about how we can make inference about population. So this is where we are and where we're going. And so AP statistics, kind of like a little bit of a course outline, really what we're doing is we're looking at patterns. We're exploring random phenomena using probability and looking at simulations with those. That's going to be a big part of this chapter. Really, this makes about 20 to 30% of the AP exam. So this is where we've been, this is where we're heading, and we can use this to kind of strengthen our understanding of probability in the beginning. So the first part of this lesson, we're going to investigate randomness. And so we're asked to record 50 imaginary flips of a coin. We can use H for heads, T for tails. Really, this is imaginary. Imagine you have a coin in your hand and you're flipping it, and it lands, and you look at it, and it's heads. So we are just going to guess, really. We are just going to make our own, what we think to be random flipping of coins. And so if I look at this, I'll start with heads. And so I have heads for my first flip. And then you know what I'm going to do? I'm going to do a tails. Let's keep it 50-50. You know what? I'm going to put 3 tails down. Tails, tails, tails. Get a little bit of a streak going. Then, got to change it up. And I'm going to change it up a little bit with 2 heads. So there we go. I have heads, 4 tails, 2 heads. Let's do 4 more tails. And then I can keep going. What's going to happen next? Man, that's, let's see, 8 tails, 3 heads. Probably need to balance it out. So I'm going to do some heads to kind of balance it out. I'm thinking, that's pretty good. So now it's pretty balanced. I'm close to 50-50. I'm thinking I'm doing this right with my imaginary flips. So let's just have a little bit of fun. I'm going to have a tails, a heads, 3 tails, and then maybe, let's go back and forth. Heads, tails, heads. That happens when you flip the coin sometimes. I like the 4 tails. Tails, 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 tails. And then a little bit of fun here. I've been sticking with streaks of 4. Let's go a little bit more. Let's go heads, heads. I flipped again. Man, 4 heads in a row, 5 heads in a row, 6 heads in a row. A little bit of fun on that one. Maybe the coin's weighted. No, it's a fair coin. Let's do 6 heads in a row. Let's throw tails in there just to give a little break. But then bam, right back to a heads. And I did 6 heads. I had a little streak. So I'm going to do some tails. Tails, 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 tails. See, that's 6. Let's do 1 more. Let's make tails a little bit better than heads. And then I'm going to have a heads, heads, tails. Let's throw 3 more heads in there. And 1 tail to end it. There's my 50 imaginary flips. Now when I'm doing this, what we're going to do next is we are going to look at a run. And a run is a repetition. I used the word when I was doing this, I said streaks. And so if I look at it, I can kind of outline these based off of the runs that I have. Now I already have these highlighted on the next slide, and so we're going to take a look at it, but just forewarning, I didn't use H for heads, T for tails. I really used icons for heads and tails, but it's the same ones. So if you look at it right now, I had a streak of 4 tails. And what that did is that allowed me to tally one of those in there. I had another streak of 4 tails here, so I tallied here. Remember, I wanted to balance it, I said, so that was a streak of 4 heads, so that went here. So I went through and I counted all of the streaks that I have. I have 3 streaks of 2. Those are highlighted in orange for my streaks of 2. I have my streaks of 3. Those are highlighted in yellow for my streaks of 3. And I have my streaks of 4, which are in green. I have no streaks of 5. Sorry. I have a streak of 6, and then I have a streak of 7 right there. I had no streaks of 8, 9, or 10, so I had no runs. So this is me being random. Just me thinking about flipping a coin, what's going to happen. Now the next part's asking us to look at, let's use true randomness. Because remember, we learned in chapter 4 that me choosing random introduces bias. I really need to be random itself. So we're going to use a random number generator, and that's why I have the NumWorks calculator down below. So to use a random number generator, we're going to do 50 flips, and we're going to record the results. Again, H for heads, T for tails. But if we're going to use a random number generator, we have to describe it properly. And so if I'm going to describe it, I'm going to let 0 equal heads, and I'm going to let 1 equal tails. So there we go. I defined what each number is going to be. I assigned a value for heads and tails, and now I'm going to say we're going to use a random number generator to select a number, 0 or 1, to represent flipping a coin. We are going to repeat this process of 50 flips, recording the results as heads or tails based on their number. Notice one thing that's different that you can see down here is that it doesn't say anything about ignoring repeats, and that's different than chapter 4. Why don't we ignore repeats anymore? Well, if I ignored repeats and I used a random number generator to pick a number between 0 and 1, as soon as I get 0, it's gone, and all I have left is 1. When we do probability, we do not want to ignore repeats because the event happening needs to be recorded. So that is one thing that's going to be different. You'll notice this chapter when we do simulations is we aren't going to ignore repeats this time. So I'm going to do that, and so I have my calculator here. And we're going to use this calculator to find how to do random number generator. And if I look at this, pull it full screen, and I have the calculator there, I'm going to choose calculator. And once I do that, I'm going to go to my toolbox. If you have the TI-84, what you want to do is you want to use math, the math button, and go over to probability. I'm going to go here and go down to probability. And once I do that, I'm going to choose random. And you'll have the same idea when you look at the probability, you'll have these options pop up. I am going to do random integer. It says random integer in A to B, so I'm going to do that, and I'm going to choose 0, 1. And once I do that, it's going to generate a random number. If I hit enter, it's going to either pick 0 or it's going to pick 1. In this case, it picked 0. So that means my first flip, 0 was a heads, so my first random flip is a heads. I do it again, it's a heads again. I do it again, now it's tails. So I have heads, heads, tails. So I'm going to do this 50 times. And I'm going to collect and record the results on the lines that we're looking at. So I'm going to keep doing this, and we're going to have our data. Now, I did this already, and it doesn't quite match what we had before, but it's really the same idea. Is I looked at it, and it's going to be a little different than what was recorded, is I had 3 zeros in a row, I had 2 ones, and so on. And once I do that, I'm going to do the same thing. I'm going to look at the streaks. I'm going to look at the runs. And so we have the same idea, is I went through, I recorded my heads and my tails, And when I look at it, what I'm going to see right here is I had used orange in order to determine streaks of 2. And so I had 5 streaks of 2. Streaks of 3 in this case, I used yellow again, and I could see that there were 6 streaks of 3. There were 3 streaks of 4 using the same colors. What was really weird in my case when I did this was there was no 5, 6, 7, 8s, 9s, 10s for my streaks. There's no 9 heads in a row. And that's actually a little bit weird that I didn't have a run of 6 or 7 or even 8. So I recorded the results. Here's what we have. So we have to ask ourselves a couple questions when we're analyzing this. We need to figure out how do the runs of our imaginary flips compare with the runs of the randomly generated flips. So we can see the table here, and we want to know how do ours relate more to the random. So the ones I chose, which is up here, versus the ones that were random, which was using the calculator. Now, when I was doing it, I guess I probably kind of cheated because I understand how this activity is supposed to go. Is when we are doing it, and I tried to explain this when I was going through the just picking my own imaginary flips, is I was trying to keep it balanced when I was doing it. And we want to do that sometimes, is when we think about probability and we flip a coin 10 times, we kind of want to go, well, it might be 5 and 5, or we expect that to happen because it's 50% probability. So we try and balance it out. Or if I do, and I did on the one before, is when I did my streak, I'm like, oh, hey, I did a streak of 6 for here. I wanted to balance it out with a lot of tails right there. So I kept on thinking I needed to balance it. Now, when we're looking at this, some people are going to be in different spots. Like, who had the longer run? Did you have the longer run? Did you put 10 heads in a row, or were they about the same? And, for me, I actually had the longer run, but for a lot of you, and this is actually written backwards, my apologies, this should be less than or equal to. Over here, a lot of you, in my opinion, are probably going to be right here. You're going to find out that random will probably do a little bit longer of a run than what you were thinking was going to happen. Because I knew what was going on, I kind of created a little bit of longer run, and my calculator just happened to be, in this case, different. That's going to become something called sampling variability. So this was the first idea of what we're looking at when it comes to probability. And then we're going to look at now kind of another activity that dives deeper into this. Should it balance out? When does it balance out to the actual expected probability? We are going to look at that and examine that question based off of an activity from Mathematic, formerly Statsmatic. And this activity has the question, is Mrs. Gallus a good free throw shooter? And the evidence of it was that Mrs. Gallus was a star basketball player back in high school. She was an impressive 80% free throw shooter. So we want to know, is Mrs. Gallus really that good? So we have some questions for us to think about is, in your own words, and this is really important, is what does it mean to be an 80% free throw shooter? So think about when you look at the weather and you see the broadcast and it says 60% chance of rain, 80% chance of snow, 30% chance of rain. You hear it all the time, but do you know what that means? So that's really what this question is asking us. Hey, if we tell you she's an 80% free throw shooter in your own words, that doesn't mean it's the statistical definition, but in your own words, what does 80% free throw shooter mean? And then once you know that, it's, hey, if Mrs. Gallus takes 100 shots, how many do you expect her to make if she's an 80% free throw shooter? So, hey, if she's an 80% free throw shooter and she takes 100 shots, what do you think she'll make? How many of them do you think will go in? And is that always guaranteed? And then the third question is, if Mrs. Gallus takes 100 shots, do you think she will have a streak of 10 in a row? So if she's an 80% free throw shooter, which, basic math in my mind says she'll make 8 out of 10, do you think she'll ever make 10 in a row? So these are the first 3 questions to think about. And what I want you to do is kind of pause it, write down your own answers to these, because this is actually developing your thought process when it comes to understanding probability. What do you think it is before we dive deeper into what it really is? So take one moment and pause. So here's what I have, is I have my answers written down. You can compare what you thought with what I have written down. Now remember, when it says in your own words, that does not mean it's the true statistical definition. So be very careful if you ever look back in your notes to go, I probably don't want to look at number 1 for where I think probability really is. So my guess was, hey, each free throw has an 80% chance of going in. That's what I thought. by the way, not the real stats definition. If Miss Gallus takes 100 shots, I would expect her to make 80. Now, I wrote a little formula down here, N times P, so 100 free throws, P for proportion, 80% accuracy, multiply them together. That's a formula that's going to come up in future units. I just wrote it down there to kind of show you that's how we figure out what we would expect. Now, it's not guaranteed, and we're going to explore this in the lesson today. So what do you think will happen? Do you think that would be streaks of 10? Again, this is your guess. It doesn't mean it's actually going to happen or not happen. I wrote down, I don't think it seems likely. I mean, if she makes 8 out of 10 shots with 80% free throw, that's what I'm thinking, 80% accuracy, what that means. I don't think she's ever going to make 10 in a row. So this is where I'm at right now as a student, my understanding of probability. So now, let's do the activity. So you can see on number 4, it says go to stapplet.com/basketball.html. And we're going to choose the law of large numbers applet. Really, this will take you right to the applet itself. And we're going to use this applet to simulate 100 free throws. And we're going to keep track of the results in the table. So results are either make or miss. You can do a check mark or an X. It's up to you. And then we're going to look at the percent made. So we're going to keep track of the percent made as we run the simulation. So let me pull up the website for us, and we can see that when we're looking at this, is Ms. Gallus a good free throw shooter? And we have it right here. It's the same exact prompt that we had at the beginning, and I'm going to hit shoot. Ms. Gallus lines up, she shoots, and she makes it. She gets the free throw. So there you go. Look down here, you can see 1 out of 1. So far, one shot made, 100%. She takes the ball again, she shoots again, and hey, she's 2 for 2. 3 for 3, 4 for 4, brick. She missed it. Bad job. But that's really interesting, isn't that? She took 5 shots, she made 4. That's 80% right now. Hey, I think that she's doing pretty good with based off of percent. And we're going to keep doing this, and this applet does time out after 50 shots. So she keeps shooting, and we keep recording the results on our table. So I'm hitting it each time just to go through. Wow, 2 bricks in a row. You can do better than that, Mrs. Gallus. And we're looking at this right here, 20 shots, and she only made 14. So wait a minute. She told me she was an 80% free throw shooter. Man, 20 shots, she's not even at 80% yet. Should I be doubting that she's that good of a free throw shooter? And we keep doing this until we get to 50. And I already have that data on my slide. And so I went through and I looked at this and I collected the data. And here is what we have. And if I want to show you, when I did this, I have right here CodeApp. And I recorded all my results, the shots as we go through, whether she made or she missed. And I looked at the percent made based off of what we had. And I graphed them on an XY axis where we have our shots, what shot number she's on, and then percent made. And so you could take a look as we went through. Shot 1 she made, 2, 3, 4. When I did the applet earlier, she made 7 shots in a row. Then she missed. And then she kept made again a couple times, and so on. So you could see this one's a little interesting. What's going on is at one point she does hit, she has 15 shots made. She made 80% of them. But then she started making more. She's more than 80. So in my case, you could see she actually did a pretty good job in my simulation. But here's something interesting. 1, 2, 3, 4, 5, 6. You can see she made a lot in a row right here. And then she made a few in a row here. And look at this streak. She made a lot in a row. She went under 80% and then kind of started to come up again, went down, and so on. And then she went around here. So we have our results. And I have it in the table. And you can see I took my CodeApp graph down here and I posted it there. So this is my sketch of all 100. I put all the dots there, what technically CodeApp did. But you can see I kept track as we went through whether she made it or she missed it. And there was a streak, randomly, of 13 shots in a row. And there was a streak randomly of 18 shots being made in a row. So that was that question. Hey, do you think she'll ever make 10 in a row? Well, if I'm surprised that she made 10 in a row, I'm even more surprised that she made 13 or 18 in a row. So there was a streak of at least 10 there. So what do I notice on this graph? And what I notice is in the beginning, there tends to be a lot of variability. Now, you may think, well, Mr. Rainsberg, there's not too much variability because, she made that many in a row. But look what happens after that. It's supposed to be 80%. But in the beginning, it's pretty there, constant. But then it drops down over 10% there. And then again, it might go here and then it drops down. I mean, these are different drops in percentages. So it has a lot of variability in the beginning. But then as we get more and more shots, notice the drops aren't as much between them. And it's starting to balance out. I say balance out. It's starting to go towards that 80% line, approach it. And that's really what's going to be going on, is in the beginning. So if we look at in the beginning, which is in this case the short term. In the short term, our probability is unpredictable. We don't know what's going to happen in the short term. We can make 13 in a row. We can make miss, or make 5, miss 1. It's going to be unpredictable. Think about flipping a coin. You can do it 5 times and end up with 4 tails. It should be 50-50 though. But as we repeat the process many times, in the long run, if we keep doing it, look what happens at the end of this graph. We can see at the end, I'll go to this, what's happening is it's starting to become, in the long run, predictable. We understand what the probability is approaching. We could see what's happening is, look at this, it's getting closer and closer to that 80% in the long run. So in the short run, probability is unpredictable. But in the long run, with many trials, we can predict probability. So that's the idea behind this activity with Mrs. Gallus being a good free throw shooter. So I already sketched the graph. We already looked at number 6. And now we're looking at in the 100 shots. Did Mrs. Gallus make exactly 80 free throws? And in this case, no. And I can go back and look. Really what I had was she made 81 out of the 100 free throws. She said she was 80%. She was 81%. So my simulation, she did better than what she said. So no, she didn't make exactly 80. But yours could have been different. I could do the simulation again and she could end up with maybe 76 free throws out of the 100. That's sampling variability. Each one of us, mine and all of yours, are going to be different than each other. But that's going to deal with what we call sampling variability. Now in the 100 shots, did she have a streak of 10 in a row? Yes, she did. It is probably not common. But after many free throws, the percent made will approach 80%. And this is the question on what does probability mean? Probability is the long run frequency. What's going to happen in the long run? It's not what's going to happen in the short run. In the short run, we have unpredictability. But in the long run, it's very predictable. So after Mrs. Gallus takes many free throws, the percent made is going to approach 80%. So that is actually the definition in how we're going to interpret probability in this lesson. So hopefully this activity helped you understand short run unpredictability versus long run predictability, and how long run predictability allows us to create a true definition for how to interpret probabilities. Now let's move on to the next one. So on your notes you have these quick notes, concepts of probability, and this is where we're going to put all of our definitions, our important properties, characteristics. This is where we're going to be looking at everything, that the meat of the lesson. So we're going to define probability, some of the characteristics of it, and we're going to look at something called the law of large numbers, which I never named before in this video, but I have described it to you. So probability. Probability is the long run relative frequency. Now we defined relative frequency back in chapter 1 with dealing with percents, and so it's the long run percent. Now some important things to keep in mind is that probability is always going to be between 0, not happening, never happening, cannot happen, and 1. Always happening, guaranteed to happen every single time. So your probabilities have to be between 0 and 1, and 0 and 1 have really important meanings. We learned in the Mrs. Gauss free throw shooting that short term, it's very unpredictable on what's going to happen. But long term, it becomes predictable. And so what I'm going to do is I'm going to do this. I'm going to go, hey, maybe that's going to deal with law of large numbers, because I'm thinking long term, large numbers. What does that mean? So let's figure that out. So probability describes the proportion. That's important. It describes the proportion. And you may think, oh, not a big deal, but I have that italicized. It does not describe the number of times. It describes the proportion of times the outcome would occur in a very long series of repetitions. So 80% free throw shooter means in the long run, we could expect her to make 80% of her free throws, a proportion. We cannot expect her in the long run to always make 80 of her free throws. It depends on how many she shoots. So if we do something many, many, many times, the proportion of desired outcomes will approach its true probability. That's the law of large numbers, which connects to that whole idea of long-term probability. So these are our quick concepts of probability that we covered so far in this lesson. Now let's put them to practice. So we have here our check your understanding problems, and we're going to take a look at it, and we have some probabilities. We have 0, 0.0001, 0.3, 0.6, 0.99, and 1. And we're asked to fill those in based off of the explanation and give an example. So first part of the table says this outcome is impossible. It can never, ever occur. Well, I'm thinking that means 0. And I need to think about an event that would never, ever happen. Ms. Rainsberg giving a compliment to a student. I would say that's probably close to 0. I might throw one out there every once in a while, so that doesn't work. Rolling a blank on a 6-sided die. Well, it can't happen. So you know what? I'm going to say rolling a 9 on a 6-sided die, because there is no 9 on the 6-sided die. This outcome is certain. It will occur on every trial. Every single time. So right here we have 100%. We could say Mr. Rainsberg being egotistical. No, I can be humble every once in a while. So we look at this, we have rolling a blank on a 6-sided die. So what will always happen if you roll a die? Well, this time it can't be one number. I mean, if I roll a die, it could be a 1, a 2, a 3, I'm going to skip 4. It could be a 5, a 6, maybe a 4. When we do this then, what does that mean? Well, if I roll a die, I get an outcome. I can get a number 1 through 6. And so really this is what we're trying to do is figure out different ways, and this can help us represent scenarios. So the next one says this outcome is very unlikely, but it will occur once in a while in a long series, a long sequence of trials. So unlikely, but will occur once in a while if I do it many, 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 many times. And so we think about this. What could that be? I already used my 0. I already used my 1. Well, it can't be the 0.99. It can't be the 0.6. I'm thinking it's the 0.001. So I'm thinking here. And then this outcome will occur more often than not. More often than not. That phrase is important. So that probably means a little bit more than 50%. But it doesn't mean it's going to occur every single time. So we have our different ones. And so I'm going to go ahead and I'm going to go through and fill in the rest of the table. But I'm also going to talk, and it's going to show the definition to number 12, the interpretation of number 2. In the Wheel of Fortune, there is a 1 out of 9, 11.1% chance of spinning a bankrupt on any given spin. Interpret that. We've already interpreted probability so far in this lesson. So when we're looking through this, here's what I have. I have for the 0.001, that's really like guessing the number properly 1 to 1,000. You have a 1 out of 1,000 chance, a 0.001 probability. A little bit more than once, so a little bit more than half is going to be 0.6. That's Mr. Rainsberg glaring at students. That's probably going to occur more often than not. Then here is our definition, and this is really important for interpret the probability. And you can see there's a little bit of a stem you see repeating so far what we've done in this lesson. After many spins, so after many trials, context, That's really what's going on right here, is whatever our context is spins on the Wheel of Fortune. The percent or the probability context of time spinning bankrupt is going to approach about 11.1%. And so really what happens is that I guess that 11.1% is going to be our context based off the problem. But you can see we really repeated something we've already talked about before. When we're looking at this, if I do something many times, whatever that context is, spins on the Wheel of Fortune, the probability, or the percent, what event am I looking at? The times of spinning bankrupt, is going to approach about whatever that probability is in the long run. So this is a interpretation of how do we actually interpret probability, which is what the first question in this lesson looked at. When we looked at the Mrs. Gallus free throw, what does 80% free throw shooter mean? Or what does it mean when it says there's a 60% chance of rain? We are looking at these things, and this is how you actually interpret probability. So we're going to look at the last question, which looks at the idea that there's 9 consecutive spins on the Wheel of Fortune. So 9 in a row, and they do not land on bankrupt. So the next contestant, he's up, he's ready to spin, now he's nervous. He's like, well, wait a minute, there's 9, and there is a 1 out of 9 chance of landing on bankrupt. It's got to land on bankrupt now because there's 9 before me that did not. So what's going to happen? And so what is wrong with this thinking when it comes to the probability with the Wheel of Fortune? And so what's really happening is we have the idea that the contestant is forgetting that it does not matter what happened on the spin before. Each spin on its own has a 1 out of 9 or 0.111111 probability, which could be 11.1% chance of landing on bankrupt. So each spin has that. Now in the long run, it's going to be predictable. So probability is predictable in the long run. In the short run, it's very unpredictable. We don't know what's going to happen. There is a lot of back and forth on the Mrs. Gallus shooting that could go there. So the contestant's thinking is wrong because they're thinking of it as like, oh no, there was 9. It's about due to be on bankrupt. And that's not how probability works. Probability works in the long run. Each spin is not affected by the outcome of the previous spin. So this was our video that kind of just went over the, I say, basics, the introduction of probability. Our main ideas here, we're looking at the idea of interpreting probability in the long run, and what you see on the screen here of short run versus long run probability. You have the law of large numbers in there, and of course look at your quick notes on some of the characteristics, definitions, and properties that deal with probability.